Hi everybody. So today we're going to be doing notes on something called solving by factoring. So this is section 7.5 in your textbook. This, just a little reminder, this little double S looking symbol means section. So if you want to look at it in your textbook, that's where you would go. So first thing I want to talk about is the definition of something called the zero product property. Basically what this says, or what this means, is that if we have two things multiplied by each other and it equals 0, then either the first one equals 0 or the second one equals 0. So if you think about this in terms of numbers, anything multiplied by 0 has to be equal to 0. So for example, with this first example, if we have this parentheses times this parentheses equal to 0, what this means, solving this using the zero product property, this means that either the first one, x plus 2, equals 0, or the second one, 3x minus 1, equals 0. And then we solve both of these for x. So this first one, I would subtract 2 from both sides to get the x by itself, and then I have x equals -2. And then for this one, I add 1 to both sides, and I get 3x equals 1. And then I would divide both sides by 3 and get x equals 1/3. So my options, my answers, are x equals -2, 1/3. Now either both of those are true or just one of them has to be true. Because if you think about it, 0 times a number equals 0, but 0 times 0 is also still 0. So they're allowed to both be 0, but at least one of them has to be. Now, in terms of what this looks like graphically, if we were to look at a graph of this function, this is our y-axis and our x-axis. What this would look like is our x value, so x is the horizontal one, is equal to -2 and 1/3. And this thing gives us a graph that looks like a U, which is called a parabola. That's what this looks like graphically. And the reason I'm showing you this is because we're going to do another unit later this semester where we're actually going to be graphing these things. So I want you to go ahead and get a little sneak peek of what it looks like. And these things, also these, words that we can use to describe these, we can call them solutions. We can call them zeros, and we can call them roots. All three things mean the exact same thing. Go ahead and pause this real quick to write down the steps for solving these. So the first example that I gave you, this one up here, that I gave you was already in factored form, just so that I could show you an example of what the zero product property is and how it works. But when you're doing these on your own, you're going to have to get these in that factored form first, which is why last unit was all about factoring. We learned all about factoring at the end. You can also use your little steps that we went through at the end of last unit for factoring to help you remember how to factor these as well. All right, so step 1 is to set this equal to 0. So I'm going to go ahead and do that. Set it equal to 0. Step 2 is to factor it completely. So the first thing I notice is that I always check for this first, remember, is that there is a GCF. What is the GCF? If you said 2, you are correct. So I'm going to factor out a 2. And what I'll be left with is x squared plus 8x plus 15 equals 0. And now I'm factoring this. So let me go ahead and underline that. I'm factoring this. I'm going to draw my big X because it's 3 terms. What goes in the top? You said 15, you're correct. What goes in the bottom? You said 8, you are correct. And then what are my 2 numbers that multiply to get the top and add to get 8? You said 5 and 3, you are correct. And we do not need to divide those by anything because our A value is 1. So when we write this out, the GCF still stays out in front. And then I have x plus 5 times x plus 3 equals 0. So now it looks like that last example, the starting point for that last example. So what we do now from here is we set each of the factors equal to 0. So x plus 5 is the first factor. So x plus 5 equals 0. And then also x plus 3 equals 0. Now this little 2 that's out in front, the GCF, you ignore this. That does not need to be included with finding your x values. The reasoning behind that is because to get the x values by itself, you divide both sides by 2, and it makes it go away, and it's still equal to 0. All right, now for both of these to solve, I'm going to subtract 5 from both sides and subtract 3 from both sides. So I get x equals -5, x equals -3. So when I write my final answer, it's going to be x equals -5, comma -3. Now I also want to point out I am writing these in order from smallest to biggest. So make sure you are doing that as well. You want the smallest number written first. Let's look at another example. So do I have a GCF? If you said 2, you are correct. So I need to factor out a 2. And I'm left with m squared minus 25 equals 0. So now what I have that I'm factoring the m squared minus 25, this is 2 terms. It's subtraction, so it's a difference. And these are both perfect squares. So this is a difference of squares. What is the square root of m squared? If you said m, you are correct. And what is the square root of 25? If you said 5, you are correct. So when we write this in factored form, my GCF stays out in front. And then my factors, one will be plus, one will be minus. M goes in the first spot, and 5 goes in the second spot. Now from here, we can solve both of these. So m plus 5 equals 0, and m minus 5 equals 0. So subtract 5 from both sides, and you get m equals -5. Add 5 to both sides, and you get m equals 5. If you want to show that step of subtracting 5 and adding 5, it's totally fine. You can do that. So my answer is going to be equal to -5, 5. But another way you can write this as well, you can write it as plus or minus 5. We looked at that notation yesterday. So you can write it either way. Oops, whichever you prefer. It's got a highlighter on my table. Let's look at another example. So first thing I notice is this thing is not equal to 0. So I need to move this -9 over to the other side. So I'm going to add 9 to both sides. And then I'll end up with 2x squared plus 9x plus 9 equals 0. So now it is equal to 0. And I need to factor. Do I have a GCF? You should have said no, we do not. So let's go ahead and do our big X. What goes in the top and bottom? You said 18 and 9, you are correct, because it's our A times C, so 2 times 9 is 18. And then the bottom is our B. And then what are our 2 numbers that multiply to get 18 and add to get 9? You said 6 and 3, you are correct. But My a value is 2. So I need to divide both of these by 2. And the 6 over 2 simplifies to 3. So when I write this out, I'm going to bring it up here just to make more efficient use of the space. I'm going to have x plus 3 times 2x plus 3 equals 0. I want you to go ahead and push pause and try solving for both of these on your own. Get what your x equals, and then push play when you're ready to check. Go ahead and check your answers. And I want to point out the -3 is written first because -3 over 2 is equivalent to -1.5 or -1.5. So -3 is the smaller number. What I want you to do now is try these 3 examples on your own. I want to point out that part A is not equal to 0, part B is equal to 0, and part C is not equal to 0. And make sure that you are checking for GCF before you factor. So go ahead and push pause, and then when you're ready to check your answers, push play. All right, go ahead and check your answers for A, B, and C. So part A, you just had to move the 50 over so that you could factor using the big X. Your A value is equal to 1, so you could just go ahead and write your factors straight from there. Part B was already equal to 0, but your A value is greater than 1. So you had to divide both of these things by 6, and they both simplified. And that would be your answer. And then lastly, part C, you had to subtract 8 from both sides, factor out a GCF, and then you had a difference of squares. And you could have written your answer either as -2, 2, or if you prefer, plus or minus 2. Totally personal preference, whichever way you prefer to write it. So basically the general idea of this is pull from your memory the different ways that we learned how to factor, and then we're just taking it one step further by setting them equal to 0. So far, the majority of this is all review, with the exception of the part that's written in blue, setting them equal to 0. Alrighty, that is the end of our notes. Have a good rest of your day.